Hello! Let's talk a little about the Grasshopper components from the development perspective. I will tackle this area from the .NET developer point of view. As a Grasshopper user, you are placing ready-to-consume components from the ribbon to Grasshopper workspace. You connect them with links, add more components, and as a result, you get the parametric script for your specific purpose. Each component has two sides, inputs and outputs. We usually think about those components as a function. They operate on specified arguments by calculating, sorting, mutating, and creating new things. We grab the results of those operations and move with them to the next component. This is how the business logic is reflected in Grasshopper scripts. And here lies the biggest difficulty in the development process. You are not just code monkey who is typing very fast at keyboard. You have to firstly think, plan how those new components will fit into the bigger picture. Please look at this from the Lego creator perspective. If you suddenly change the connection way of your bricks, it will not fit to the rest. Your users will complain that you broke the existing contract, some basic assumptions of the Lego world. So please, don't look at the development of Grasshopper components only from the technical point of view. Your .NET skills are important, of course, but the overall success is a combination of two main phases: planning and execution. So, let's plan new drawing component, level mark inserter. We want to wrap existing Tekla OpenAPI functionality. Let's check the documentation. Okay, there are plenty ways to create level marks. If we compare different constructors, we would see that all have three main inputs. View base, which is the drawing view holding the level mark. Each view has its own coordinate system, so it's crucial to specify it during creation of the drawing object. The next one is the insertion point of level mark, and it means the point where the text of mark will be placed. Lastly, the base point, from which the level value will be taken. Every Tekla drawing object has a lot of specific attributes, usually get from preset file from the environment of or model directory. At this point of Tekla Drawing Link, I prefer to give the user ability to specify ready-to-consume attribute file. This shifts the workload to the user. She has to provide settings needed for desirable look of the output. We will prepare a component with 4 inputs. The 3 of them will be obligatory: further view and 2 points. The last will be optional. If user will not provide attribute setting file name, then we will just go with the standard one. Okay, inputs are clear. What about the outputs? In this case, there will be just one, freshly baked level mark. Probably it will be not modified by next components, but we should always provide at least one output. It makes preserving the flow of our script much easier. Time for coding. Let's open the solution and check which places have to be modified. Components directory definitely looks worth to check. Here you can find all of the component definitions. We have to create the new definition. Assuming crude naming convention, let's type create level mark component. Every Grasshopper component have to inherit from the GH component base class. In the drawing link, it is wrapped with Tekla component base class. It will force us to provide necessary information for the Grasshopper purpose. After implementing abstract class, we have to generate public constructor. Here, first convention appears. There is a specific class, component infos, for holding some basic component properties. Each component has a name, nickname, description, and location on the ribbon. We have to create the new static property for this class, which will be the holder of needed information. So let's just name it like create level mark component, and then name. It will be level mark and the nickname level mark combined, and here some kind of description. Creates level mark and the specified point. Okay, and here is the problem, because we should place it somewhere in the ribbon, but probably at this point it does not belong to the drawing section, nor the view, nor the geometry. So just for the placeholder, let's go with miscellaneous. Okay, but why we created this property? Because now we can pass in the constructor of the newly created class this specific property. So component infos. Let's add missing namespace, and here, by doing this, now we are going to the upper class, and it will create the new Grasshopper component with the specified properties. Nice, we have it. But there is one more thing based on the convention. Here it is visible. Each of the Grasshopper components, each of the custom Grasshopper objects need its GUID. GUID, generally unique identifier, so the number with letters, which is created with a special algorithm, which is unique for this kind of a component. It is needed for saving the Grasshopper component, for getting the proper distinction, what is what. And here in the Tekla Drawing Link, it is resolved by some static method, which will just get the GUID from the already saved dictionary. So we have to add the new record in this dictionary for our new component class. It was create level mark component. And here the main thing, this number, this GUID, has to be unique. So let's generate a new one, and just this. Okay, let's remove what we don't need, and now we are 100% sure that this GUID is unique. And that's the base thing for creation of the new component. So you have to specify its name, placement on the ribbon, but also you have to specify the GUID of it. Okay, base things are set up. Now let's go to those three not implemented methods. We have the left side of the component, the input side. And as I said previously, here we need 4 parameters, 4 inputs. 3 of them will be obligatory. The user has to specify the view, which the level mark will be placed, and also two type of points. And the last one, the setting file, is not mandatory. Okay, so let's check how it is resolved, those input parameters, because as always it is much easier to get those from some examples. So let's see, create detail view. Okay, and here in the section of the registering of the input parameters, we have the parameter manager from the Grasshopper, where we are specifying new type of the parameter. And here there is our custom type, custom object, Tekla Drawing View parameter, which is with the specified type. And I think that it should be placed in a totally different material. The whole topic about Grasshopper goose. The name is quite funny, but it is the way how objects are wrapped between the Grasshopper components. This is the technical possibility to convert one type of objects to the another one, because you can quickly get the concept when you look at the point. Point in Tekla, using the Tekla Structures Geometry 3D namespace, is just the placeholder for 3 coordinates. It has a bunch of methods, but generally it's just 3 points. But it is specified in the Tekla library. Of course, the concept of point is much bigger. Yes, the point exists almost everywhere. So also in the Rhino itself, there is different definition of point. And from the user perspective, yeah, it doesn't matter if the point is from Tekla or from the Rhino. It just needs to have these X, Y, and Z coordinates. So by specifying some GUI objects which are placed in the type, you can quickly, for example, this one, create the way of casting. So if it will be inputted as a grasshopper point, then we would like just to wrap it as a Tekla point, just a simple mapping with those properties which are truly needed by the user. But yeah, I think that those GUIs need separate material because they're quite big. So let's go back to the input. So as I said, we need the view, which will be the placeholder for the level mark itself. And also we need points, 2 points. So let's see, okay, we have here point manager, point parameter. Let's copy this and say a little better how it should be named. What was that? It was the insertion point. Okay, let's go. And it will be insertion point, the shortest version IP. not so obvious, but yeah, the description should be more the descriptive insertion point of the level mark. Okay. The next thing, as I remember, it will be the base point. Okay. And yeah, here is the main problem, but because as I see those arguments, I would say that yeah, base points should be rather upper one, but yeah, don't maybe change the how the API is. So yeah, but this is a tricky question. Base point of the level mark, and the last one I said that it should be optional. So the name of the standards, and here we can see this little helper method, which is in the abstract class, at text parameter, where we can specify the attributes, and it has the last argument as an optional. So it has the default value set as false, but it is for showing that yeah, this parameter is not obligatory. So the component will work without it. Okay. And it should not be the name, I think, but the settings itself. So yep. Okay. Here we have the 4 inputs, and now at the output we would like to add just created level mark. And as I said previously, this level mark probably will be not modified, so I will not wrap it with any type of GUI. I will just go with the same convention like for those detail mark. I will add the generic parameter. What is the generic parameter? It's any type of object. So we don't care how exactly those transformations will be done, because probably we will never edit it, but also it is very hard to find the corresponding object at the Rhino itself of the level mark, because this concept is quite Tekla-centric. So let's go with it like it is. And now when we have the registered input and outputs, of course, we have to somehow create this level mark, yes, because now we just get the 4 parameters and we expect that at the end we will get the level mark. But here the method solve instance, which is responsible for the logic of the component, is empty. It is now throwing some exception. So let's see how the getting of the data from the input to the solve instance method is resolved. So yeah, there are some extension methods. Let's just copy some of them and use them. So yeah, exactly like the same in the detail mark, we at first need to get from this interface data access past values by the user. So we are getting the view, sorry. Yep, we have the view, the first argument, and then we are getting the insertion point. So let's change maybe insertion point. And yeah, this is something which there are 2 ways of getting the data in this method. You can get them by the index itself. So you just specify the index that, yeah, you assume that at the first position of the input list or array, it will be something. But also you can get more tight coupling, I would say, when you are not vulnerable for the changing of the input parameters. And this convention for getting those input parameters by the name, not by the position on the input list, it is used in this link. Of course, it is not, there are pros and cons, but okay, now let's go with the logic of the creation of the level mark itself. So yeah, here we get the input. So we have the view, insertion point, base point, and also we would like to get the text file. So let's check how it was done. Okay, so view attributes. Okay. It was like this. Oh, okay, here it is. Something which I was missing. So I will just change this text parameter for a little different thing. And yeah, it was set as default, not... Yeah, damn it. Okay, so in the past it was resolved a little differently because I showed you this add text parameter, this method of get from the abstract class, and it is heavily dependent of the instance description. So at first you have to create some placeholder with the name, nicknames, the descriptions. And as I see that in the past, I used a little different approach where you just specify the default value of the parameter. So this method is provided by the Grasshopper itself. It is part of its API. So here, the last argument is the default value. So we can change it that, it will be named as mark attributes, and it will be named like level mark attributes file name. This line will be unnecessary. We can remove it safely and change this shortcut to the MA, and maybe different convention with the naming of the second word to the small letter. Yep, sorry for a little of house, but yep. Now we can just copy and paste this section because it is responsible for getting the attribute name, and probably in the future it will be moved to some standard way of doing, because as I said, it is very easy for the developer to just pass this duty to the user that, hey, you are the user, so you know which attributes should be placed. And maybe here we will get level mark attribute file name. Okay, attributes file name. Okay, and of course here is the main thing, level mark attributes. But at this line we will just get the name of the file. It can be empty, then it will be just the standard one, but it can be different. So now we have to create the level mark and level mark attributes. There it is. So now we will initiate the attribute file. We also have the view, the insertion point, the base point. So let's just check if the creation of the level mark, new level mark, and use the constructor. Now we have to provide the view, and what next? The insertion point, and of course here we are getting the Rhino object. So this mapping is done to the Rhino object, and there's the extension method to Tekla point, which will just grab those coordinates and save them as an Tekla ones, which are needed in this constructor. Then the Tekla point, and the last one, attributes, level mark attributes. Okay, here it is. Maybe let's just grab it. It will be a little easier to. Oops. What? Wow. What? Wait. Why? Okay, let's move it by this one. And the last thing, this object now is only created. We have to insert it into the drawing space. And the last thing is committing the changes, because both at the model side and at the drawing side, every object created and added to the database, it needs to be committed. So let's do it. And for this purpose, there is the static class drawing interactor, which has the commit changes method. What is the drawing interactor? It is only once initialized class, which is the placeholder for the drawing handler, so the entry point of the most important things with the communication with the drawing API. Okay, so we just read inputted values, converted them to the Tekla object, inserted it, and committed changes to the drawing database. But we missed one point. We did not set the output itself, because you have to see these registering things as only the declaration that, yeah, during the solve instance, during its running, we will provide the output now with the generic parameter, and we have to do it now. So let's see how it was. Yep, and it was done like this. If this object was really created, then it is set with the parameter name like mark and name. Yep, this is it. So once more, there are three main things. You have to specify the info of the component, so the name, the description, the placement on the ribbon. You have to also specify the GUID itself, so just add the new record in this preset dictionary. Please don't just copy and paste existing GUID, because it will be found out during the Grasshopper initialization, and you will get the warning that two types of different objects have the same GUID. And the last thing, which is probably the most important, you have to specify what will be the input of your component, what will be the output of your component, and also what is the logic behind the creation of the component. And yeah, that's all. So now I think that we should just compile and build our solution, our component, and check if it is working. But before we will jump into the Rhino, there is one thing which was not changed. By default, the newest version of Visual Studio is creating classes with the internal specifier, so it will be not found by the Grasshopper during the initialization. We have to change it to the public one, and now we can see, we can check how the project file is built itself. So here you can find out that at the beginning, at the start of the debugging session, it will start the Rhino itself at the specified path with the Grasshopper initialization. So just by starting the debug session, it will start the Rhino, pop up the Grasshopper, so we can check how it will be working. And of course, it is working. It will load the current version of our link, because I have specified the debug directory as an red path in the Rhino itself, but this is the matter probably for the different video. Now I would like just to check if this new link is available at the miscellaneous. Yes, it is. It does not have the icon because we do not provided it, and it can be grabbed to the ribbon. So what do we need? We need the view itself. So let's grab the view maybe from the drawing part. We will just select this hollow core and use component father view. Okay, now we will get the view base. It is the section view. Okay, the next one, the insertion point. Okay, so now, yeah, let's just assume that user will pick the insertion point. We would like maybe not insertion point, it should be the base point. So we want to measure top of this hollow core, and the insertion point, it will be a little different. It will be the, yeah, we are on the right side of the hollow core, so let's just move 100 drawing units to the left, 100 millimeters, and for this I will use the maybe move component. Yeah, it needs the geometry, and also it will need the motion, so we have to specify the translation vector, and maybe use the construct. Yeah, it can be the point. So let's set that it will be moved by 100 millimeters. Here it is, the input geometry. Yes, and yes, we are 100 millimeters on the to the right, and now let's check it will work. Yeah, 100 millimeters is probably too low, so let's change it. Yep, now we have it moved to the right. Of course, now we are using some predefined settings, so those arrows can be changed and saved with a different name, and maybe the value 0 is not I don't trust it, so let's change the input point to the bottom of this hollow core, and yeah, here it is much better. And of course, if we will specify different Y coordination, so for example 50 millimeters, we will get a little different output, but it should be changed to get your needed appearance. How do you perceive this level mark? So basically that's the whole point. When you at first think how bigger numbers are much better, maybe 100 millimeters, or yep, now it is better. Okay, so let's grab it all. At first you have to think which part of the Tekla OpenAI API you would like to grab. For this example, it was the level mark, where there is the clear documentation about the different type of constructing of this type of object. Then you have to move the argument side. So this special level mark, it has a different set of constructors. I said that yeah, we will be based on this one, this specific one, where there are 4 parameters, and the output is the level mark itself. So this is the planning part. You pick the part of Tekla OpenAPI, think about the input, outputs, and that's it. After this, you are creating new class and the drawing link where you are registering input, outputs, and of course you have to specify the name, nickname, and also the GUID of your component. So if you look at the references, it should be in also this GUID static helper class. And the last thing is the solving thing. So you have to modify, to create. It all depends about the behavior of this component. Here we had the creation of the level mark, so it was just creating the Tekla OpenAPI object based of the input of the geometry. Okay, it was, I think, first time when I was recording my programming, and it's quite difficult, I would say. So sorry for for all of those entangled pieces. I hope that you will get the core point. If you have any questions, then please ask them. I think that there are a lot of different things touched during this video, so probably some of them should be covered in a separate material. So please give some feedback and see you later. Bye.